Listen, if you've ever felt the agonizing pain of trying to securely transfer files between two machines, wrestling with SSH keys, messing with firewalls, or just relying on some clunky third-party service, you are absolutely going to love Drift. Today, in this explainer, we're unpacking its major v0.5.0 release, an update that honestly takes this really elegant zero-setup solution and turns it into a total precision instrument.
Just to quickly set the baseline for us, Drift is a single binary application built for encrypted, bidirectional file transfer. It connects two machines over a WebSocket and actually serves an embedded, two-pane web UI right to your local host. It's incredibly straightforward. The left pane is your local machine, and the right pane is your connected remote machine. You can just push, pull, and navigate right there, seamlessly.
So here's our roadmap for the breakdown. 1. A quick core architecture overview. 2. Enter protocol version 3. 3. The new remote browse API. 4. Path autocomplete and UI. And finally, smarter connection lifecycles. Let's get into it.
Starting with Section 1, Core Architecture Overview. Encrypted transfer, no setup.
The tech stack here is seriously impressive. We're talking a backend powered by Rust, using Axum and Tokio for incredibly high performance and concurrency. On the front end, it is fully modern. React 19, Vite, TypeScript, and Tailwind CSS v4. But really, the star of the show is the security. Drift uses x25519 for key exchange and ChaCha20 Poly 1305 for end-to-end encryption. You even have optional password authentication with an HMAX challenge response, and it wraps all of this up beautifully by just embedding the front end straight into the Rust backend using Rust Embed.
And because of that embedded architecture, Drift is distributed as just a single binary. It really lives up to its core tagline, encrypted file transfer, no setup. You don't have to install dependencies, and you definitely don't need to mess with web servers. You literally just grab the binary from Homebrew on a Mac or download it from their GitHub releases, and bam, you are instantly up and running. Oh, and it also features CLI subcommands for headless operation if you're someone who prefers staying strictly in the terminal.
Now, as networks get more complex, developers obviously demand more reliability. The tool itself needs to become more precise, and the v0.5.0 release tackles this from multiple angles. We're looking at a protocol upgrade to v3, the introduction of correlation IDs, a brand new remote browse API, some really slick UI improvements like tab completion, and unique instance IDs. We're going to unpack each of these updates right now.
Moving to Section 2, Enter Protocol version 3, Multiplexing Requests.
Okay, so in older versions, messages were sent across the encrypted WebSocket tunnel, and the system kind of just waited for the next response in line. But now, multiplex request and response tracking completely changes the game. It works like this. A message goes out with a unique request ID, and the response comes back with that exact matching ID. Drift now ensures specific responses map directly back to their originating requests, literally no matter what order they cross the network in.
So, what WebSocket control messages actually carry these new IDs? Well, whether the system is requesting a directory listing, fetching peer info, sending a heartbeat ping, or returning an error, every single one of these messages now includes an optional UUID field called Request ID. This totally eliminates the guesswork for the front end. It knows exactly which request failed or succeeded at any given time.
Now, you might be wondering, what if I upgrade my local machine to v0.5.0, but the remote server I'm connecting to is still running an older version? Well, the devs thought of that. They put in a FIFO, first in, first out, fallback queue called pending response order. This ensures backward compatibility for older peers that just don't support these new request IDs. There is a very slight risk of response mismatches if multiple concurrent requests go to an older peer that echoes them incorrectly, but for standard day-to-day operation, this queue safely bridges the gap between the versions.
Section 3. New Remote Browse API. Precise REST routing.
The old way of fetching remote directory files relied pretty heavily on shared WebSocket state and cache data, which, honestly, could be a bit fragile if things got out of sync. So the new v0.5.0 approach fixes this by introducing an explicit GET request to a standard REST endpoint, specifically /API browse remote. Instead of leaning on that shared state, the new browse remote handler basically proxies the request directly to the connected remote peer. Then, it uses a Rust feature called Tokio.sync.oneshot to wait for that specific correlated response we just talked about. It effectively bypasses all that messy shared state entirely.
Section 4. Path autocomplete and UI refined navigation.
Navigating through directories using an address bar just has to be fast and fluid. By tying together that new remote browse API and the protocol upgrades, the developers basically revamped the whole path bar component. It now genuinely feels like a perfectly functional, no-nonsense developer terminal.
And let me tell you, these front-end tweaks make a massive difference in your daily workflow. First off, they extracted the logic for root relative path resolution, so path parsing is incredibly robust now. The app state explicitly tracks the root directory for both the local and remote panes independently. Plus, as you type, the autocomplete dynamically pings that new /API/browse remote endpoint directly. Add in some fixed tab key behavior for flawless autofill, a super simple click-to-place cursor instead of that annoying auto-selection on focus, and automatic scrolling to follow your active suggestion. The whole navigation experience just feels instantly snappy and responsive.
Which brings us to Section 5, Smarter Connection Lifecycles, Beating Network Drops.
Picture this: your Wi-Fi flickers, and the remote node unexpectedly drops the connection. We've all been there. It's a universal developer headache. But Drift immediately initiates an automatic reconnect, and the brilliant part is, your credentials survive, so you aren't suddenly locked out. But here is the real v0.5.0 magic. A new, totally unique instance ID is generated for this fresh connection. So, when the old ghost connection finally times out in the background, a cleanup process checks this ID. Because the ID is changed, it simply ignores the stale tasks. This ensures the system never accidentally tears down your brand new, healthy connection.
Drift was already a fantastic tool for bypassing all the usual headaches of secure file transfers. But with v0.5.0, throwing in multiplex request tracking, explicit REST routing, and these highly intelligent connection lifecycles, it's become incredibly robust. So I'll leave you with this. Is your current file transfer workflow this precise? Or is it maybe time to finally ditch the clunky alternatives and upgrade to a true, multiplexed, single binary solution?